what if the AI tools you're integrating into your company workflows right now, like the exact ones you just spent the last 8 months mapping out and deploying, are already fundamentally obsolete?
Yeah, that is a completely terrifying thought for any CTO.
Right. I mean, imagine this scenario. A major financial institution has just achieved, say, 90% automation for their routine customer inquiries.
Which is a massive operational victory on paper.
Huge. It's a total win.
Mm.
But simultaneously, that exact same institution is staring down a 30 million euro fine from European regulators.
Wow, 30 million.
Yeah, 30 million. And why? Because they literally cannot explain the underlying mechanics of how their AI systems actually arrived at those automated decisions.
Right, the whole black box excuse.
Exactly. The black box is just no longer legally acceptable.
Yeah.
So the question we're exploring today for every business leader listening is whether your infrastructure is genuinely prepared for the era of agentic AI.
And that really is the multi-million euro question facing enterprise architecture today.
It really is.
So, our mission for this deep dive is to dissect a specific, highly relevant playbook on this exact transition.
Yeah, we've got some great source material today.
We do. We are analyzing AetherLink's Agentic AI and multi-agent orchestration, Enterprise Guide 2026. And, I mean, the data driving this guide is pretty stark.
Oh, absolutely.
Like, 74% of enterprises are currently increasing their AI spending, but, and this is the key part, they are entirely shifting their procurement strategies.
Right. They're not just buying the same stuff anymore.
Exactly. We're seeing a massive pivot away from investing in, single monolithic large language models.
Yeah, the migration is moving toward what the AetherLink guide defines as egentic workflows.
Right.
We are basically moving from isolated single-function tools to these interconnected digital teams.
Which is a huge leap.
It is. And to really understand the architectural demands here, we have to look at the transition from the standard conversational AI models of like 2024 to these autonomous multi-agent systems.
Yeah, because they are fundamentally different beasts.
Exactly. So we're assuming you already know how a basic prompt and response chatbot functions, right?
Sure.
The leap to agentic AI is about systems that maintain state, perceive a changing digital environment, reason through multi-step logic, and this is the big one, execute complex workflows without a human having to constantly turn the crank.
Right. Let's frame this shift around the concept of orchestration.
Okay. Yeah.
Because a standard LLM is highly capable, obviously, but it's fundamentally reactive.
You have to talk to it first.
Exactly. An agentic system, on the other hand, introduces proactive autonomy. You're building a system where specialized agents are assigned specific domains of authority.
Right.
And the guide introduces this really fascinating operational paradigm it calls the AI composer.
Oh, I love this kind.
It's great, right. In this model, the enterprise user or the developer is no longer just an end user typing instructions into a prompt box.
You're not just chatting anymore.
No, you become a systems designer. You configure specialized agent teams for highly specific business outcomes, and you establish the rules of engagement for how they actually collaborate.
Let's ground this with a structural analogy for the listener. Think about a high-end commercial kitchen.
Okay, I like where this is going.
So the isolated AI tools from a couple of years ago function like a highly advanced microwave.
Right.
You input a specific parameter, you hit start, and it performs one discrete task very well. It heats the food.
Sure, but you're still doing all the real work.
Exactly. You, the human, are doing all the prep, the sequencing, the plating. But an agentic AI framework operates like a head chef managing a full kitchen brigade.
Oh, that makes total sense.
Right. You don't tell the head chef the internal temperature requirement for the poultry. You pass them a ticket that says, Table 4 needs a 5-course tasting menu, one diner has a severe peanut allergy, and the courses need to be timed to a 2-hour window.
And then they just handle it. And, the mechanics of how that ticket gets processed, that is where the enterprise value is generated.
Because the head chef isn't actually cooking every dish.
Exactly. They decompose that complex goal into subtasks.
Yeah.
They delegate the vegetable prep to the sous chef, the sauces to the saucier, and the desserts to the pastry chef.
And that delegation and timing, that's what the guide refers to as multi-agent orchestration, right?
Spot on. It's the precise choreography of specialized digital workers managed by this overarching layer called the agent control plane.
Okay, so let's look under the hood of that agent control plane for a second, because it isn't just a simple router that passes messages back and forth.
No, not at all. It's much smarter than that.
It acts as the state manager for the entire workflow. It uses something akin to a directed acyclic graph, or a DAG, to map out the dependencies of a task.
Right, because order matters.
Exactly. Like,
Yep.
if the pastry chef cannot start plating until the main course is cleared, the control plane enforces that logic.
It's the ultimate project manager.
Yes. It dictates which agent gets called, what context they receive, and how their output is evaluated before moving to the next node in the graph.
But, the effectiveness of that control plane immediately begs a larger question regarding data integration.
Oh, for sure.
Because an autonomous digital workforce is completely useless if it cannot interact with your proprietary enterprise systems.
Right. A kitchen brigade locked in a room with no ingredients cannot serve a meal.
Exactly. So this requires looking at two critical infrastructural pillars: retrieval augmented generation, which we know as RAG, and the model context protocol, or MCP.
Okay, so we all know the basics of IGA, right? It grounds the AI's generation in your specific enterprise data to prevent hallucinations.
Yeah, that's the standard definition.
But in a multi-agent orchestrated system, our RAG becomes incredibly complex.
Oh, exponentially more complex.
Because we're no longer talking about a single chatbot querying a single vector database. We are dealing with multi-agent semantic collisions.
Semantic collisions. That sounds messy.
It really is. Say a customer initiates a complex dispute. The dispute resolution agent queries the standard corporate policy database and retrieves a 30-day refund limit.
Okay, standard policy.
Right. But the VIP customer success agent simultaneously queries the dynamic loyalty database, which grants a 60-day window for premium members.
Ah, I see. So you have two agents with conflicting truths.
Exactly. And the orchestration layer has to resolve that collision instantly.
Right. It requires hierarchical retrieval logic where the control plane evaluates the source weight of the conflicting data streams before passing a unified context to the execution agent.
It has to know who to trust, basically.
Exactly. But retrieval is still only half the equation. Reading data is passive.
Right.
For an agent to take action to actually process that refund, it needs a bridge to the outside world. And that is the function of MCP servers.
The model context protocol.
Yes. It establishes a standardized architecture for agents to securely connect to external APIs, whether that's a web browser, a proprietary CRM, or a legacy financial system.
Which is huge, because MCP prevents your engineering team from having to write bespoke API wrappers for every single agent and every single tool.
It saves thousands of hours of dev time.
Absolutely. Let's trace a practical enterprise workflow to see this in action.
Okay, let's hear it.
Say a client submits a complex invoice discrepancy. Agent 1, the intake specialist, analyzes the email and extracts the relevant entities.
Simple enough.
Right. Then Agent 2, via an MCP connection to your Salesforce CRM, verifies the client's contract terms.
Okay, so it reaches out.
Exactly. Then Agent 3 takes those contract terms and queries your ERP system to cross-reference the billing history.
Wow.
And finally, Agent 4 drafts a resolution proposal and queues it in your ticketing system for human review. The control plane coordinated that entire sequence autonomously.
And the return on investment for that level of orchestration is just incredibly compelling.
I can imagine.
The AetherLink guide actually provides data from the financial sector, indicating that early adopters are achieving up to 90% automation on routine operational inquiries.
90%. That is massive.
It's staggering. But more importantly, they are deploying vertical AI for hyper-personalization at scale.
So really tailoring the experience.
Yes. 85% of these institutions are driving 10 to 25% revenue growth by deploying agentic teams.
Wait, really? 25% growth just from this?
Yeah, because they have setups where one agent analyzes real-time user behavior, a second agent runs a risk compliance check, and a third generates a custom product offering instantly.
That's incredible. And we see similar architectural shifts in healthcare, too.
Oh, absolutely.
Microsoft recently documented a multi-agent system that entirely decouples administrative tasks.
Like what kind of tasks?
So they deployed independent agents for patient intake, clinical decision support referencing medical guidelines, and secure appointment scheduling.
That makes a lot of sense.
Yeah, by separating the domains, they drastically reduced clinician burnout.
Which is a huge issue in healthcare right now.
Right. And in the enterprise content space, platforms like Writer are utilizing generating agents to draft material, entirely separate reviewing agents to audit that draft against strict corporate brand guidelines, and personalization agents to adapt the final approved text for different regional markets.
Wow.
Yeah, they're documenting production speeds 3 to 5 times faster than traditional single model workflows.
I mean, the operational benefits are crystal clear, But we have to acknowledge that deploying this introduces severe architectural bottlenecks.
Okay, yeah. What kind of bottlenecks?
Well, when you transition from a single model to a multi-agent framework, you are introducing network hops.
Ah, right. The agents talking to agents.
Exactly. If a customer is waiting on a live support interface, and Agent A has to query Agent B, who then queries an MCP server, who reports back to Agent B, who formats it for Agent A.
That sounds like it's going to take forever.
It does. You're stacking inference times and latency. A 30-second wait time for an automated response is a complete failure condition for user experience.
Yeah, nobody is waiting 30 seconds for a chatbot to reply.
Exactly.
So solving that latency requires fundamentally rethinking the communication architecture.
Completely.
You cannot rely on synchronous communication where Agent A sits completely frozen, blocking the main thread while waiting for Agent B to reply.
No, that crashes the system.
Right. So the engineering solution involves implementing asynchronous message queues.
Yeah, the event-driven models.
Exactly. We are looking at event-driven pub-sub models, similar to Kafka or RabbitMQ.
Right.
Agent A publishes a request to a topic in the queue and immediately moves on to process other parallel tasks. Agent B subscribes to that topic, processes the request when it has compute availability, and publishes the result back.
And you also see a heavy push toward edge deployment to mitigate this latency.
Oh, really? Like keeping it local?
Yes. By hosting specific lightweight execution agents closer to the user's local environment or device, you drastically reduce the network travel time for those micro decisions.
Okay, that makes sense.
And then you reserve the heavy cloud-based orchestration models purely for the complex reasoning tasks that require massive compute.
Okay, wait, hold on. This brings up a massive contradiction in the architecture.
Uh-oh. What is it?
You just outlined the necessity of edge deployment in asynchronous queues to shave off milliseconds and eliminate bottlenecks.
Yeah, speed is critical.
But earlier, we established that European regulators are threatening €30 million fines if we cannot perfectly explain how these systems make decisions.
Ah, yes, the compliance issue.
Right. The EU AI Act demands centralized, immutable audit logging for high-risk applications. If every single micro-decision, handoff, and reg retrieval has to be written to a centralized ledger, doesn't that massive data logging instantly destroy all the latency gains you just built?
That is the exact tension at the heart of enterprise AI right now.
Writing to a central database is like the textbook definition of a bottleneck.
It is. How do you maintain speed while ensuring absolute cryptographic proof of reasoning? You cannot have the primary inference thread waiting for a database write confirmation before moving to the next step.
So what's the workaround?
The technical solution the industry is adopting involves asynchronous sidecar logging.
Meaning the telemetry data is stripped out and handled by a parallel process.
Precisely. The agent's core container executes the logic and passes the payload forward immediately.
Okay.
Simultaneously, a lightweight sidecar container attached to that agent captures the metadata, what context was retrieved, the confidence score of the decision, the routing path, and streams that telemetry asynchronously to a centralized, immutable ledger.
Ah, so the agent doesn't actually wait for the ledger to confirm receipt.
Exactly. It just fires and forgets the log while keeping the main process moving fast.
This highlights the compounding risk of multi-agent systems, particularly regarding hallucinations, doesn't it?
See,
In a single model setup, if the AI hallucinates a fact, the user sees it and hopefully catches it. But in a multi-agent orchestra, we face the threat of cascading failures.
the domino effect.
Exactly. If the retrieval agent hallucinates a data point and passes that fabricated fact to the execution agent doesn't know it's a hallucination.
Right. It has no idea.
It treats that input as ground truth and acts on it. You get a chain reaction of automated errors happening at machine speed.
And mitigating that cascade requires defense in depth within the orchestration layer. The primary mechanism is rigorous confidence scoring.
So like grading the output.
Basically, yeah. If a retrieval agent returns data with only a 65% confidence metric, the control plane must be configured to halt the automated workflow.
And do what?
Either flag the payload for human review or route it to a specialized verification agent. You basically have to build adversarial architecture into the system.
Adversarial architecture. That sounds intense.
It just means you deploy independent validator agents whose sole function is to audit and attempt to disprove the outputs of your execution agents before any action is finalized.
Wow. And under the EU AI Act, getting this architecture right is not merely a best practice. It is a strict legal requirement.
Oh, absolutely.
For business leaders listening to this deep dive, the stakes are existential. If your multi-agent system touches healthcare, financial services, or employment decisions, like filtering resumes, you are legally classified as a high-risk AI system.
And that's where the massive penalties come in.
Yeah, the penalties for non-compliance are up to 30 million euros, or 6% of your total global revenue, not just your European revenue, total global revenue.
And the guide makes a really critical point about this regulatory environment. Compliance cannot be an afterthought.
You can't just bolt it on later.
Exactly. You cannot build a multi-agent system optimizing purely for speed and then attempt to bolt an audit trail onto it 6 months later when regulators come knocking.
It'll be a complete mess.
It will. The demand for explainability requires that centralized exportable audit logs are engineered directly into the control plane from day one.
The AetherLink guide evaluates various approaches to this, objectively analyzing platforms that offer built-in compliance telemetry.
Right.
They point to frameworks like AetherDV custom AI agents as examples of infrastructure engineered specifically for this regulatory burden.
Because if an auditor walks into your firm and demands to know why a specific loan application was denied by your automated system 3 months ago, you cannot just point to a neural network and shrug.
The black box did it. Yeah, that doesn't fly.
No, you have to export a log showing the exact directed acyclic graph trace showing Agent A gathered the income data, Agent B queried the credit bureau via an MCP server, and Agent C applied the bank's risk threshold logic to trigger the denial.
That level of visibility is incredible. But knowing the sheer complexity of this architecture, from semantic R collisions to sidecar logging for compliance business leaders, really need a pragmatic approach to implementation.
Yes, and thankfully the guide details a highly structured 2026 deployment playbook. It breaks down into 4 phases: assessment, piloting, measuring, and partnering.
Okay, let's walk through those.
So the assessment phase goes far beyond just asking if your data is clean. It demands an audit of your governance maturity.
Right, because if your internal data is a decentralized mess of conflicting SharePoint folders and outdated PDFs with no access controls, your highly advanced multi-agent system is simply going to confidently execute workflows based on outdated garbage.
Garbage in, garbage out at machine speed.
Exactly. You have to establish strict data taxonomies before you deploy an orchestration layer. Once that foundation is set, you move to the piloting phase.
And the golden rule here is bounding the experiment.
Start small, right?
Exactly. You do not attempt an enterprise-wide rollout. You isolate a single, well-defined business process like vendor invoice reconciliation, and you assign maybe 2 or 3 agents to it.
And during that pilot, the metrics you track are fundamentally different from traditional software deployment.
Oh, completely.
The measuring phase requires monitoring specific multi-agent telemetry. Yes, you track the overall task success rate, meaning how often the agents resolve the invoice without requiring a human override.
Standard stuff.
Right. But you also have to monitor metrics unique to orchestration, like agent loop entrapment.
Loop entrapment is such a fascinating failure mode.
It really is.
Yeah.
It happens when agents get stuck in an infinite cycle of correcting each other.
Oh, like arguing.
Basically, Agent A drafts a summary, Agent B reviews it and flags a formatting error, Agent A fixes the format but introduces a spelling error, Agent B flags the spelling.
And they just bounce the task back and forth indefinitely.
Indefinitely. Just burning compute resources and API costs. So the control plane has to be configured with circuit breakers to detect those loops, terminate the cycle, and escalate to a human manager.
That leads directly into the necessity of automated governance at scale.
Yeah.
When you scale from a 3-agent pilot to a 300-agent enterprise deployment, human oversight of every transaction becomes physically impossible.
You can't watch every log.
No. So the control plane must enforce hard-coded policies. It requires strict rate limiting to prevent a rogue orchestration loop from burning through 10,000 euros in API calls over a single weekend.
Yikes. That would be a bad Monday morning meeting.
It's a terrible meeting. And it also requires granular permission controls, ensuring an external communication agent physically cannot access the secure database containing personally identifiable information.
So the guide's final phase is partnering. It provides an objective look at the reality of building this infrastructure.
Which is tough.
Very tough. For the vast majority of internal enterprise IT teams, engineering a multi-agent control plane from scratch while implementing async message queues, managing MCP connections, and ensuring sidecar telemetry compliance with the EU AI Act is simply too heavy a lift.
It's just too much for an in-house team to build from zero.
Exactly. The guide suggests leveraging specialized architectural partners. They note EtherMind for high-level strategy and governance mapping, and AetherDV for the actual technical build-out and integration.
And the underlying argument there is that the technology is iterating too quickly for traditional procurement cycles to keep up.
Yeah, you need agile partners.
Exactly. Looking at the trajectory of the industry, we are entering an era of hyper-specialization. A supply chain optimization agent and a legal compliance agent will soon operate on entirely different foundational models and architectures.
Right.
And the only way these diverse models will communicate is through strict adherence to standardized protocols like MCP and unified audit trails.
Without standard communication layers, orchestration across an enterprise simply collapses.
Completely.
Well, we have dissected a massive amount of architectural strategy today, from shifting from reactive tools to proactive brigades, to the mechanics of multi-agent RI, async queues, and navigating the intense regulatory requirements of the EU AI Act.
It's a lot to process.
It is. Let's distill this into actionable insights. My primary takeaway from the AetherLink 2026 guide focuses on the changing nature of human talent. The concept of the AI composer democratizes systems engineering. You no longer need a PhD in machine learning to build an advanced AI workflow. You don't need to train the neural network.
Right.
You just need to understand systems thinking. The challenge has shifted from writing code to designing orchestration. You are curating, directing, and managing a team of highly capable digital experts to achieve a specific outcome.
That is a great perspective. My overarching takeaway centers on the regulatory tension we explored. Governance is no longer an administrative function or a legal checkbox managed by the compliance department.
It's an engineering problem now.
Exactly. It is the foundational engineering challenge of this decade. Architecting your control planes and audit trails correctly is not just about avoiding a catastrophic 30 million euro fine. It is a profound operational advantage.
Oh, absolutely.
The enterprises that figure out how to trace multi-agent decisions flawlessly and asynchronously under the EU AI Act are the ones that will be granted the regulatory trust to scale their automation the fastest.
They build the infrastructure of trust directly into the code base.
Exactly that. And as we look ahead, there is a profound structural question to consider for everyone listening.
What's that?
We have detailed how these agentic systems are evolving to autonomously orchestrate complex tasks, delegate responsibilities, and execute decisions at machine speed.
Right.
If these control planes become perfectly optimized and the agents coordinate flawlessly, how does that reshape the enterprise organizational chart in 5 years?
Oh, wow.
Are we approaching a reality where we have digital employees reporting to human managers? Or will we see the inverse human workers finding themselves executing the physical, real-world tasks that were routed and assigned to them by an AI orchestration layer?
That is the paradigm shift every leader needs to prepare for. For more AI insights, visit AetherLink.ai.